Hi, in this video we're going to be talking about the queue data structure. So let's get started. So what exactly is a queue? Well, queues are sequence containers just like lines or even stacks. And when I talk about lines, I want you to imagine like an actual line of people. So when you have a line of people, the first person in that line is the first person out of that line, right? Now, like I mentioned earlier, queues are kind of like sequence containers. And we've also seen a previous sequence container called the stack. But the difference between a stack and a queue is that a queue is first in, first out, meaning the first element to be in the queue will also be the first element out of the queue as long as we're using the queue normally. The difference with that is that a stack is last in, first out. So whatever we put at the top of the stack is going to be the first thing that we can take out. And lastly, queues can store any type of data. So they can store int, double, string, and even custom objects and classes that you've created yourself. So here's a quick short image of what's happening in a queue. We have the front of the line and the back of the line, similar to any queue in real life. So what are the main operations for queues? Well, we actually have 4 of them. The first one is onQueue or inQueue, which basically means that we're putting someone at the back of the line almost. We have back, which is just a reference to the back or the last element in the queue. We have dequeue, which basically means take the first element in that queue or the front element and remove it from the line or queue. And we also have front, which is a reference to the front element or the first element in the queue. So let's talk about these in a little more detail. So inQueue or onQueue is like adding a person to the back of the line. So alternative terms may be adding or offering. And so you can see a little image here that we have in queue, which is just adding a person to the back of our line. If we imagine that the left side is the front and the right side is the back. We also have dequeue, which is like removing a person from the front of the line. And alternative terms is polling. So these alternative terms you can actually see in Java's programming language, where if you want to remove something from a queue, we'd write queue.poll, and inQueue is like queue.offer. So these are different terms in different programming languages that you might see. So you can see dequeue is just taking that first person and removing them from the line because they no longer need to be used. So where can we use queue and what are the use cases? Well, the queue gives us access to the earliest inserted element. It's best to use a queue when dealing with chronological priority because we get the earliest inserted element, graph theory such as BFS, and in real life, we use them in web server management. For example, first come, first serve kind of schemas. Okay, so these are some of the use cases. Let's look at an example of where we could use a queue. Well, a queue, let's read this problem. So given a string that contains digits 2 to 9 inclusive, return all possible combinations the number could represent. Return the answer in any order. A mapping of digits to letters is given below, and we can see that 1 doesn't represent anything. And so, yeah. So you might not understand this question right now, but let's look at a quick example of what's happening. So let's say we had the input 2, 3, so 23. Well, the output could be AD, AE, AF, BD, BE, BF, CD, CE, CF. And why is this the case? Well, 2 could represent either A, B, or C, and 3 could either represent D, E, or F. Okay, so the idea, and we'll explain it in a bit, is going to be coded up soon. Okay, so let's talk about the code. Right now, all I have is some boilerplate code that basically takes in a string, which is just our digits, and then it prints it out as all of the string on one line. Then I also have this combination or letter combinations method here, which takes in a string digits and returns a vector of strings, which is basically a dynamic list of strings, which are all the combinations of the digits. So the first thing that we can do really is we can just check whether or not it's empty. And this is a really good practice because whenever you see a question that takes in anything really, you want to first check the smallest and most trivial cases. And in this case, it's going to be if it's empty. And for example, for objects such as trees, we might want to check whether or not it's null first. So let's return empty braces here, which basically means it's an empty list because there's no combinations that we can make. The next thing that I'm going to do is I'm just going to create an unordered map, which is the same thing as a hash map or a dictionary in Python. And what it is it's going to map the numbers to the strings that it corresponds to. So I just pasted it in right here. And this is done to save time. Of course, if you want to do this yourself, the phone number or the mapping was already posted in the video earlier. Okay, so the first thing that I'm going to do is I'm going to create a queue which is full of strings. And this queue will store strings because this will store our answers that we found so far. So whenever we see a number, what we're going to do is, what we're going to do is we're just going to extend that number and try all the numbers with a new number. So for example, if I have A, B, C, D, E, or let's just say ABC, and I see, for example, a 2. If I see another 2, what I'm going to do is this is going to become 3 more strings. This is going to become ABCA, it's going to become ABCB, and ABCC. Then from there, each one of those are going to be mapped again. So for example, if I see a 3 after that, well, what's going to happen to this one here is this is going to become ABCAD. It's going to become ABCAE, ABCAF, and so on and so forth. And the same thing happens for this string as well. Okay, so first what we need to do is we need to take care of our most basic cases. So we're going to say for every character C in the dictionary of digits 0. So this is basically saying take care of the first number. So we're going to take care of the 2 first. So we see this 2 and we go to ABC. What's going to happen is we're going to put in our queue those first 3 letters. So we're going to say q.push string 1c. This basically converts the character into a string so that we can actually put it into our queue because this is of type string. Okay, the next thing that we're going to do is we're now going to process each of the letters one by one. So we're just going to go through all the digits now. So digits.size, I++, and we're going to actually take the length of the current queue because we want to process all of those numbers first before dealing with the rest of them. So we're going to say this is equal to int of q.size. And what we're going to do is we're just going to loop a few times. So I'm just going to loop L or length times. So we can do that many ways. We can just do some kind of for loop like this. I'm going to use the variable L because it stands for length. And what we're going to do here is we're just going to take out the current queue or the current element that's at the front of the queue. So we're going to say string output is equal to q.front, q.pop. So essentially what's happening here is, okay, imagine we have ABC, A, comma, B, comma, C. What's going to happen is we're going to be looking at this 3 now because we already finished the 2, which is the first digit. We're going to be looking at this 3 here. And what's going to happen is we're going to go through these letters. And I'll extend it by 1 more just to show a better example. So we have this 3 here. And what's going to happen is we're going to go to the dictionary for 3, right? And what's going to happen is essentially we're going to extend each of the letters or each of the output strings by each of these letters. So this A becomes AD, AE, and AF. The B becomes BD, BE, BF, and the C becomes CD, CE, CF. Oh, sorry, C. And then once we're done with those, now our queue actually just contains these new strings. So let's take these new strings and paste them here. So these are my new output strings. And now what's going to happen is I'm going to take the length of this and extend it by 1 more by 4, for example, and so on. So let's keep this as 2, 3, so that we know what the output is. And so right now what we're doing is we're going through all the current outputs. And going through the current outputs, what we're going to do is we're just going to say, okay, for every character in dict digits I, so this is for the new letter, right? So this is for the new number, for example, the 4. We finished 2, 3. Now we're just going through the 4 now, because the queue actually contains the previous elements so far. So what's going to happen is my new output is actually going to be the old output plus a j, right? So all we're doing is extending one of the old outputs by a single letter right now. Okay, and we're going to do that 3 or 4 times for every letter. For example, PQRS, that's 4 times, DEF, that's 3 times. Then I'm going to say q.push, new output. Now, the reason why we don't need to worry about this q.push going into an infinite loop here is because we're actually taking the length of the current queue so that we're only dealing with the current elements. Any new elements won't actually get iterated over. Okay, the next thing that we're going to do is we're just going to pretty much print out our queue. So the way we print out our queue, because once we're done all this looping here, what's going to happen is our queue is going to be full of the answer. So what we're going to do is we're actually just going to print out the queue. And the way we have to do that in C++ is that we need to return a vector string, right? So what happens is we need to basically just take all the elements in our queue and put them into the output. So while the queue is not empty, we're basically just going to take the current element, so q.front, and then pop our queue. And we're just going to say output.inplaceBack or push back the current string. Simply return the output, and let's see if it works. And there we go. So it works perfectly fine. And that's pretty much it for letter combinations.